So thank you everyone for attending this talk. Today I'm going to talk about product ranking on online platforms. And it is a joint work with Mahsa Derakhshan from University of Maryland, Vahideh from Yale, and Vahab Mirrokni from Google. Okay, I'm going to start this talk with one of my online shopping experiences. So when I moved from California to the East Coast, I really wanted to buy a pair of women's slippers. So I went to Amazon and I searched for a pair. And Amazon showed me more than 43,000 search results arranged in 400 pages. So as you can imagine, I didn't have time to go over all of these like 43,000 search results. I look at few of these products appearing in the first page and I purchased something and it wasn't that bad after all. To this day, I like the pair that I ended up purchasing. So apparently, I'm not the only consumer that is very selective and looks at a few set of products to make a purchase. According to Millward Brown, which is one of the largest market research company, 70% of Amazon users do not even bother going to the second page of search result, yet alone going to page 400. So this highlights two important issues. The first thing is that on online platform, most of the products are going to be invisible to the consumers. And then the second important issue is that the products that are placed in better position, for example, those that are placed in the first page are going to be more visible to the consumer. And as a result, they are going to have a higher chance of getting purchased. So keep these two things in your mind, and now let me show you more evidence that highlights the impact of positions on consumers' behavior. So we had access to query level data from a large online platform. And by analyzing that data set, we got this figure that shows probability of click versus positions under two different rankings: random ranking, which is the blue one, and the platform's ranking, which is the red one. So one thing which is interesting here is that even under random ranking, we can see that the probability of click decreases with position. So, and then another interesting finding is that we can see the probability of click in lower position is actually higher on the random ranking compared to the platform's ranking. So you may wonder why actually this is happening. So the main reason for this finding, we believe, is that on the random ranking, it's very likely that the products that you see, that the consumers see on the top position are not going to be really relevant. And that's going to motivate the consumer to scroll down further the page and then see more products. And based on this, we can say that the products that we place in the top position impose some externality on the products in the lower position, and that's why the probability of click is actually decreasing. And more importantly, the better the products that you put in the top position, the higher the externality, and that's why the probability of click for the lower position is actually higher on the random ranking. Okay, so based on this observation, here is our main research questions. We want to understand how should the platform rank the products given the consumer search behavior, and then considering the fact that the products in the top position impose externality on the products in the lower position. So what you are going to see in this talk is as follows. So first, I'm going to present a two-stage consumer search model that can capture products externality and consumer search behavior. And then for that model that we propose, I'm going to characterize the consumer optimal search strategy. Then after that, okay, I'm going to focus on the platform's problem, which is a ranking problem under two different objectives that we consider. One is market share, which is the probability of purchasing something on that platform. And then the other one is the consumer welfare. So we show that both of these problems are NP-hard, and because of that, we focus on approximation algorithm. We develop Pitas for this problem, and we also analyze the performance of a simple greedy algorithm. Okay. So here's our model. We have n products that we indexed by I, and we have n position indexed by j. And position with the small indices have more visibility. So for example, here position 1 is the most visible position. So platform is going to display these products to a consumer in form of an ordering. In other words, the platform decision is a permutation pie. And here is, for example, here I'm just going to show you an example of such permutation. Okay, so the platform objective function when it comes to this ranking decision is it can be like two things. One is maximizing its market share, where the market share is the probability that the consumer takes the desired action. Where the desired action can be clicking on something, purchasing a product, or installing an app. But then in the rest of the talk, just to simplify things, whenever I'm talking about market share, I'm just assuming that I'm maximizing the probability of purchase. And then the second objective function is maximizing consumer welfare. So we focus on these two objectives because we think that online platforms mainly care about their long-term objective, and because they want to make sure that the consumers keep coming back to their platform. And then by focusing on these two objectives, we believe that the platforms can achieve their final, their long-term business goal. Okay, so now let me walk you through our two-stage search model. And I'm going to start with explaining how we model the utility of each product I. So the utility of each product I can be written as two terms. The first term, which is the log of WI that we refer to as preference weight of product I, is called intrinsic utility. This is a part of utility which is the same across all the consumer. And the second term is the idiosyncratic part of the utility that is different across consumer, and we put it there to capture the idiosyncratic tastes of different consumers. So WI, or these preference weights, are drawn from some distribution f of W, and ZI is drawn from some from the Gumbel distribution. And for those of you who are familiar with assortment planning literature, so Gumbel distribution is pretty common in that literature. So both of distribution are common knowledge. Platforms and consumers are aware of these distributions. But what is important here is that consumer neither knows WI nor ZI. And the reason we made that assumption is actually goes back to the example that I showed you earlier. So in my own personal shopping experience, Amazon showed me like 43,000 search results, and it's kind of like for such setting, it makes sense that we assume the consumer does not have any idea or doesn't have any information about any of the products that he or she is supposed to see. But we assume that the platforms knows the preference weight of the products, and then the platform can access to such information by via analyzing the historical data set that it has access to. Okay, so now let's talk about this two-stage search model. We assume that the consumer learn about WI and ZI in a two-stage process. In the first stage, the consumer is going to screen the products to learn about their preference weights. And then after that, the consumers forms a consideration set. This is going to be all the products that at the end of the day, the consumer is going to consider purchasing. In the second stage, the consumer is going to learn about the idiosyncratic part of the products within her consideration set. And after these two stages, the consumer is going to choose the products that is going to give her the highest realized utility. And to make sure that we allow the customers to leave the platform without making any purchase, we also have this outside option whose weight is normalized to 1. Okay, so now let me give you more information about the consumers. We assume that we have K types of consumers, and these consumers are different in terms of their search cost. We have this screening cost for every position J, which we denoted by SJK, and we assume that the top positions are the ones that they have lower search cost. And that makes sense because the top position are the ones that they are more visible to the consumers, and this assumption is also in line with the marketing literature that they use the data to estimate this search cost. And then another assumption we make is that the consumers of type K is less patient than the consumers of type K plus 1. So what is important here is that the platform does not observe the type of consumer, but the platform knows the type distribution. And the fact that the consumer does not observe the type of consumer makes the problem actually very challenging for the platform, because now the platform needs to offer a ranking of the product that pleases different type of consumers that have different patience level. Okay, so now you know I described the model. Let's focus on the optimal search strategy of the consumer in the two-stage search model that we proposed. So, and I'm going to focus on the first stage where the consideration set is being formed. So to form a consideration set, consumers are going to undergo a sequential search process. At every stage of this search process, the consumer decides whether or not to stop her search. And if she continues the search, she decides which position to screen next. And the objective function of the consumer is going to be maximizing her expected welfare, where her welfare is the expected utility of the purchased product minus all the search costs that the consumer needs to pay in order to screen the different products. And note that this utility that I have here is the final realized utility. And because of that, when the consumer needs to decide how to conduct her search, she also needs to consider the second stage where the idiosyncratic part of the utility will be realized. So here's our main theorem for this part of the result. So we show that the consumer optimal search policy is an simple index-based policy that I'm going to describe in the next slide. So to explain this index-based policy, just to ease the discussion, I'm going to assume that I only have one type of consumer, but of course, whatever I'm saying can be extended to more than a single type. So in this index-based policy, for every position J, we have an index Rj, where this index Rj depends on distribution of the preference weights f of W and the Campbell distribution, and also it depends on the search cost for the different positions. But what is crucial here is that if you have a position that has a small search cost, we expect that this index to be also larger for that position. So in this index-based policy, the consumer is going to start examining the position from the top because the products, in fact, the consumer is going to examine the product in decreasing order of these indices. And because of the top position has the smallest search cost, that means that the consumer is going to start from the top. So the consumer first is going to learn about the preference weight of the product in the first position. And then she's going to stop if W1 is going to be greater than the index of the second position. And if the consumer stops, the consideration set of that consumer is going to only be the product in the first position. If she does not stop, she's going to learn about W2, and then she's going to stop if some of the W1 and W2 is greater than the index of the third position. And then this will continue. If she does not stop, she's going to go to the third position because the third position has the third highest index for the consumer. And then she's going to stop if some of the W1 and W2 and W3 is greater than R4. And this process will continue. Okay, so remember at the end of the day, after learning about this preference weight, the consumer is going to go to the second stage to learn about the idiosyncratic part of the utility, and then after that finalize her decision. A couple of things that I want to highlight here is the following. So first of all, if we put a really good products in the top position, I mean by good products, the products that has a really high weight. So by doing so, the consumer is going to have a small consideration set because it's become very likely that one of these stopping rule is satisfied earlier on. And the other thing is that, as I mentioned earlier on at the beginning of the talk, so the products that we put in the top position impose externality on the products in the lower position. And in fact, the better the products, the higher their weights, the higher the externality is going to be. And finally, another important thing, which is a novel aspect of our model, is that here in our model, the formation of the consideration set is endogenous and is a function of ranking itself. So if I change the ranking, the set of the products that the consumer is going to consider is going to be different. Even the size of that is going to be different. So in the interest of time, I'm not going to go over the related literature, and I'm going to jump into the platforms problem. And then, and at the beginning, I'm going to focus on the first objective, which is going to be maximizing market share. So when it comes to the platforms problem, one thing which is important is that the platforms knows more than the consumer. The platform has access to all the information about the preference weights, and the platform would like to use that in knowledge to find the ranking that maximizes the market share, which is going to be the probability of purchase. So we have this theorem that says, unfortunately, this problem, this market share rank maximization problem, is NP hard, even if we have one type of consumers. Okay, so then it is very, so then we are going to focus on designing approximation algorithm. And one natural candidate is the greedy algorithm that just simply sort the products in decreasing order of their weights. And the greedy algorithm is, from the practical perspective, is very appealing because it does not really need to know anything about the consumers. It only needs to know the preference weights. But then I know that our NP hardness results shows that the greedy algorithm is not optimal, but then you may wonder intuitively why it's not optimal. So the reason greedy algorithm is not optimal is that the greedy algorithm is not engaging enough. So greedy algorithm puts really good products in the top position. And because of the stopping rule that the consumer is going to follow, by putting the good products in the top position, the consumer is going to have a small consideration set. So, but you may also wonder, how does it perform? Because a lot of online platforms use greedy algorithm in practice. So we show that the greedy algorithm has a good performance, and then the greedy algorithm is getting at least half of the optimal and opt minus 0.17, and this bond that I'm presenting here is actually tight. So then the next question is that, can we do better than the greedy algorithm? And the answer is yes. We designed Pitas for this rank maximization problem, which complexity scales quadratically in the number of types. The idea of this Pitas is based on some bucketing procedure that you are rounding up the weights, but just following this simple procedure is not going to work out, because the error in the rounding weights is also going to impact your estimation for the consideration set. And then as a result, we needed to restrict this dynamic programming that we run on top of this bucketing approach to follow the low weight priority rankings. That I'm not going to go to the details, but if you're interested, I think that's an interesting novel aspect of the proof and the design of the Pitas. So the next objective that we focus on is maximizing consumer welfare. And for maximizing consumer welfare, we have this result. NP hardness is still there. Greedy algorithm performs pretty well. And we also design a Pitas whose complexity is scaled linear in the number of types. The previous Pitas, because of the search cost in the objective function, is not going to work here. And we needed new idea to design Pitas here. Okay, so let me conclude. We designed a new two-stage consumer search model that captured product externality, the product externality on lower position. And then we show that under our two-stage search model, the formation of the consideration set is endogenous. And then if the products see better products, they're going to stop their search earlier on. The main insight here is that even if the platform wants to maximize its market share or maximize its consumers' welfare, ranking products in decreasing order of their weights is not going to be optimal. But nonetheless, this greedy algorithm and ranking in that way is it has a good performance guarantee. And we also design an approximately optimal algorithm for both of the objective, market share maximization and consumer welfare. So thank you very much. This is my email in case you have questions, and this is a link to the paper. Thank you.